My friends, let's see how you did. So for part A, when you see the notation P sub zero, what they mean is they're looking for a 0-degree polynomial. That's what that little subscript 0 means. And then it kind of makes sense to say of x, because every time you'll give almost every time you'll give an answer in terms of x. So for part A, I hope it makes sense that, so f of x is e to the x, and really we just need at 0, we need this 0-degree polynomial to have the same y coordinates. So basically, this is just going to be f of 0, which plugs 0 into e to the x, and you get 1. So if you said p sub 0 equals 1, then you nailed it. Anyway, so congratulations. You can totally handle 0-degree Maclaurin polynomials, or also known as 0-degree Taylor polynomials centered at 0. But that's harder to say. Okay, now let's look at this one right here. So the next one is a first-degree polynomial, and we want it to have everything that the 0-degree had, but more. So p sub 1 of x, the sub 1 just means first-degree polynomial. So we want it to have this y coordinate in common. So we want it, f of 0. And then we also want it to have the slope in common there. And so that would be f prime of 0, f prime of 0 for the slope, and then times x, since you've got a line graph there. So part of the reason that I chose f of x equaling e to the x for our first one is because, it's because, its derivatives are always the same, so it's pretty easy to work with. So f of 0 was 1, f prime of 0 would still be 1. So your answer for p sub 1 of x would be 1 for f of 0, and then plus 1x, or just x, for f prime of 0 times x. So anyway, if you wrote x plus 1, that actually makes a little more sense as well. But I'm going to have the terms kind of written in ascending or power of x instead of descending like we usually do. You'll see why pretty soon. Okay, if you don't already. So I'm going to simplify this one more step, and we would say 1 plus x. So, all right, so hopefully those first two went pretty well for you. And then the next one is where you'll probably get stretched the most. And you're going to have to think harder for this first example than you ever will again, because after this, we just give you the formula and you just do it every time, and it's super fun. But I wanted to make sure you had some chance to have a little respect for the formula, which is what this example is about. So now let's go on to p sub 2 of x. So what did we want for p sub 2 of x? A lot. We wanted this parabola here, second-degree polynomial, to have 3 things in common with e to the x. We want the y coordinate at 0 to match, so that would be f of 0. We want the first derivative to match, so that means we still need f prime of 0 times x for the first derivative to match. And now we want the second derivative to also match. And so if you were thinking f double prime of 0 times x squared, then you almost had it. I'm going to talk with you about why you'd actually need to have a divided by 2 on this one. So let's talk about that. And actually, let's simplify it first. I think that sounds fun. So what's f double prime of x? It's still e to the x. So f double prime of 0 would still be 1. So for this one, if you fill things in, f of 0 would be 1. F prime of 0 is 1, so you still have 1x there. And then f double prime of 0 is 1 again, so you'd basically have 1/2 x squared. Okay, so how come we need this over 2? Well, because we need the derivative of p sub 2 to equal p sub 1. And so, if you take the derivative of 1, you get 0. If you take the derivative of x, you get 1. And then if you take the derivative of 1/2 x squared, with the 1/2 there, you would get x. But without the 1/2 there, you wouldn't have gotten that. And so hopefully that makes sense that little over 2 has to be there. Okay. All right, my friends. So now that we've gotten you past P sub 2, I wonder if you could figure out P sub 3 and P sub 4. Okay, so see how it goes. Check in with me in the next video.